So our final lecture on stocks sort of addresses the weaknesses of our first two models and tries to come up with a comprehensive model that'll work. Unfortunately, it's still going to have some weaknesses, but it's better than the first two models we presented here. We call it the two-phase pricing model. It's often called the non-constant growth model. So our goal here is to develop this model, learn the features of it, and work an example. So the features of this model is really almost, I like to call it a two-phase model. You have phase one where your dividends can grow at any growth rate. So you can allow for rapid growth in a company. You can allow for a firm, say for instance, not to pay a dividend for a certain time period. And then we start phase two. At the start of phase two, we're no longer confident in what we think the firm is going to do. So we apply our infinite model to phase two. We let dividends grow at a constant rate. So what you're going to find here is in phase one we have varying growth rates for dividends, so we're going to grow those dividends out. And then at the start of phase two we're going to take that dividend and grow it at a constant rate, and we're going to price the remainder of the stock's life. So we call this the non-constant growth model or the two-phase model. So let's just summarize the steps. So step one, find all these phase one dividends. Now this is where we have non-constant growth in dividends. Step two, we find the value of all dividends beyond the end of phase one. So in other words, we let that final dividend start growing at a constant rate. And then finally, stage three, we add up our two present values and get a price of the stock. So hit pause and read the following example. Now this example is about as complicated as a two-phase problem can get. As you see, over the first 5-year period, which is going to be phase one, we actually have two different growth rates in dividends. For 3 years, dividends grow at 10%, and then for years 4 and 5, dividends grow at 8%. So that's our non-constant growth stage. Now at the end of that 5th year, we're no longer very confident about what we think the stock's going to do. So conservatively, we assign a constant growth from that point on. So for this example, after the 5th year, we're going to grow at a constant rate of 5%. Now it still says as an investor we require a 15% rate of return on this investment. So what price would we pay? Or in other words, what's our intrinsic value? So let's run through the solution. First, our first step is to find the value of all phase one dividends. So if you recall, dividends grow at 10% for the first 3 years and then 8% for years 4 and 5. There's a couple of ways you can get at this, but I just like linking one dividend to the next. So the dividend at time 1 would of course be the $1 of dividend we just paid times 1 plus the growth rate of 10%. The dividend then at year 2 would be dividend at time 1 times 1 plus G. So we take that $1.10 we just solved for and multiply by 1 plus the growth rate again. We do the same thing for year 3. We take the year 2 dividend of $1.21 and we multiply by $1.10. So now we shift our growth rates. So at year 4 we grow at 8%. So we take the year 3 dividend of $1.33 and we multiply by 1.08 or 1 plus the growth rate, and we repeat for year 5. So we have our 5 dividends now for phase 1. Now that's really like a uneven cash flow stream if you think back to time value of money. So we need to find the present value of these today. So in other words, what value do I place on these dividends today? We're going to discount the cost of capital, which is 15%. So we set up our cash flow stream where we discount each cash flow individually or each dividend individually from phase 1. By using our calculator, we use the cash flow key or the cash flow function. So cash flow times 0 is 0. Now we don't include the $1 because it's already been paid. So anybody buying this stock today will not receive that dividend. So it's not part of our valuation. This is a common error here. Cash flow 1 is the year 1 dividend. Cash flow 2 is the year 2 dividend. And so forth. We go all the way out to year 5. Then we hit the NPV key and we put in 15 for the interest rate, as in 15%, and we compute the NPV. We take the present value of the dividends and we get $4.34. So that's the value of our phase 1. Next, we look at phase 2. Now we know at the end of year 5 we're no longer confident in assigning growth rates to the dividends, so we conservatively assign a constant growth rate. Now we need that last dividend at year 5, which is $1.55. And we're going to create what we call the Gordon growth model, which is really a growing perpetuity if we think back to time value of money. So we'll take the dividend at year 5, we'll grow it out 1 year, and then we'll divide by R minus G, where R is our discount rate and G is our growth rate long term in dividends. So here it would be $1.55 times 1.05 divided by the interest rate of 0.15 minus the growth rate of 0.05. Let's look at it on the next page. There's our calculation. So the selling price at year 5 is $16.28. Now really what this tells us, this is the value of all the dividends beyond year 5. So really it's what I could sell the stock for in 5 years, because someone would be buying all the dividends from year 5 on. Well, the problem is this isn't valued today. We're trying to put a price on the stock today, so we need to discount this back to the present. So we treat the $16.28 like a future value, and it's a lump sum. So we find the present value of a lump sum by taking our $16.28 and dividing by 1 plus the interest rate to the 5th power, because it's 5 years away. We get 809. So now our final step is we take the present value of phase 1 and we add it to the present value of phase 2. That gives us our intrinsic value. Now, this is one of the hardest things we do in this unit, so please work some extra problems. I'll try to have a few up on our web page to give you practice on this important concept.